Okay, so hopefully you have already done number 1 and 2 and you're just checking your answers. So take a moment, pause if you need to, double check your work. What I want you to notice here is that when you integrate, you're going to get a function. Notice that you're integrating from 0 to x, so even though your original function was sine of t dt, you end up with a function in terms of x. Also notice that you don't end up with a plus c because this is a definite integral. Even though you have a function, it's kind of like it calculates the c for you because you're integrating from 0 to x instead of from, instead of in terms of x. On number 2, the difference here is that we're integrating and then taking the derivative. So if you remembered what we had talked about, I don't know what classwork it was a little while ago when we talked about the fundamental theorem of calculus. When you integrate and then take the derivative, if you're integrating from a constant to a, when you're integrating from a constant right here to x, that x actually goes in place of the t, and then you don't have to do a plus c, okay? So there's our final function. That x replaces the t, the constant goes away, as we can see when we're taking the derivative, that constant that we got is going to go away. Okay. Next we're going to talk about how to find the general solution, or solve a differential equation. What I want you to know here, we talked about this last time in class, is that when you find a general solution, you have to separate your variables. Separating your variables means that I'm going to, let me zoom in a little bit here, I'm going to multiply both sides of this function by dx, so that what I get is dy, because the dx's cancel, equals, I'm going to rewrite that cube root of x to the third, square root of x to the third as x to the 3 halves plus 3x minus sine of x, all of that times dx. And now I can integrate both sides, and my variables are separated, which means that I can go ahead and just integrate like normal. Integral of dy is y, and over here I'm going to integrate like normal. I'm going to add 1, let me change colors here, I'm going to add 1 to this exponent and then divide by that number, so that 1 is really 2 halves, 2 halves plus 3 halves is 5 halves, so I get x to the 5 halves, and then I have to divide by that new number, so dividing by 5 halves is the same as multiplying by 2/5. Same over here, I'm going to add 1 to the invisible exponent of 1. So this guy has a 1 exponent, I'm going to add 1 to that. So I get x squared, and then I have to divide by 2. So I'm going to get 3 halves x squared. Now I'm going to think about sine, or negative sign. How could I get a negative sign from a function? Well, if I take the derivative of cosine, that would give me a negative sign. So a regular cosine of x gives me sine of x. And I can't forget my plus c, and that is my final answer. That is the general solution. So no different than what we've been doing before. General solution just means find the integral. The difference here is that when we have a dy dx, that we have to separate variables, and that's a really important thing to do. Okay, so separating variables just means getting all the y's on one side and all the x's on the other side. Alright, let's go, oh, come here you. So let's do another one. I'm just going to start this one off for you and let you finish it. So the first thing I have to do is multiply both sides by dx to get the variables apart from each other, to separate those variables. Okay. I would probably rewrite some of this, so when I do my dy equals, I'm probably going to write that as x to the negative 6 plus 8 minus x to the 3/4, all of that, dx. And now at this point, I can go ahead and take my integral of both sides and go from there. So you go ahead and do that. And pause. And I'm going to go on to another problem here. Oh, I'll go ahead and give you the answer. Well, no, I'm not going to give you the answer. Okay, so now I'm going to talk about number 4 and finding a particular solution. Particular solution just means that we know enough information that we can find our C value. Okay, so particular solution, find C. And in this case, we don't have to separate our variables because it's f prime of x, and that's basically like a y prime. However, if I would have been given a dy dx, I would need to separate my variables. Okay, so that's always the case. If you have your variables separated, you have to do that first. General solution means you're going to have a C in your answer. Particular solution means you're going to find out what number the C is. So let's go ahead and do that. So the first thing we're going to do is just integrate both sides. So really, when I integrate, I should add a, maybe I should have rewritten this. I should add a dx. Okay. Integral of f prime is just f of x. Integral of 10x, well, that would make an x squared. 10 divided by 2 is 5. Minus, let's see, x cubed would become x to the 4th. And then divided by 4 is minus 3. And then I have my plus c. But I also know that f of 3 is equal to 2. So f of x is 2, and my x is 3. And now you can see that I only have numbers here. If you do the calculation, I believe you will get 200 equals C. That's just, calculator or brain. And then my final answer is that f of x equals 5x squared. So I'm taking the, this part that I got, and plus c, except I know what the c is. So 5x squared minus 3x to the 4th plus my c value, which is 200. That's the particular solution when we have, when we're at the point 3, 2. Next I'm going to talk about one that is kind of a double problem here, because we have a double prime. So I'm going to do the same thing. I'm going to do the integral and the integral. You should probably pause here and see if you can figure out what this would be. In this case, when I integrate f double prime, I'm going to get f prime equals, let's see, so that would be a negative cosine would give me a positive sign, plus c. And again, I have some information here that I can use. I know f prime of 0 equals 1. So my x is 0 and my y is 1, basically, although it's actually a y prime in this case. Okay, and then I can solve for c. Cosine of 0 is 1. 1 equals negative 1 plus c. And then I add 1 to both sides. Okay, so now I know that f prime of x equals negative cosine of x plus 2. So far, so good. But I actually want to find f, so I'm going to integrate again. And when I integrate again, so I'm going to integrate this. And when I do that, dx. Okay. So integrating negative cosine, a negative sign would give me a negative cosine. Integrating f prime gives me f. Integrating negative cosine gives me, sine of x. Integrating 2 gives me 2x plus c. Okay. But again, I have some information to work with. I know that f of x, which is basically y, equals sine of 0 plus 2 times, oh goodness, not enough room, 0 plus c. Sine of 0 is 0, 2 times 0 is 0, 0 plus c is c. Okay, so now I have my c value. So now I know, how small can I write this? F of x equals sine x plus 2x plus, 6. Didn't make it. Okay, and that is my final answer. So you can see it's the same process, just doing it twice. Alright, so I would like you to continue working, do the rest of this worksheet, and I will be checking, look at the board for the items that I will be checking on Wednesday when I see you again.